So let's look at this one a little bit closer. So one of the things that we need to know is that n with the exclamation point is really, in mathematics, n factorial. A factorial is that exclamation point, which is why sometimes you'll see these jokes about exclamation points in math. So a factorial is the product of all positive integers equal to or less than the given number. So what that means is when we have something like 5 factorial, what that means is we're doing 5 times 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1, we have 20 times 6 times 1, so is 120. Our fun fact is that, unless you have some really extraordinary circumstances, no one will reach their 5 factorial birthday, so 120. So your last factorial birthday is 24. 4 times 3 times 2 times 1. So don't forget your 4th factorial birthday. So we're going to make a table to kind of look at what's happening with our function here. So we're going to make a table. It's going to include n, that counting number of what kind of step we're on, n cubed, and n factorial. So we're starting with 1. 1 cubed is 1. 1 factorial is 1. So they're all kind of the same. So if we were to divide them, it would still give us 1. 2 cubed, 2 times 2 times 2 is 8. And 2 factorial, 2 times 1 would be 2. So right now, as of this moment, n cubed looks like it's going to be growing at a faster rate. 3 n cubed, 3 cubed is 27. 3 factorial, 2 times 3 is 6. So at this current moment, it's looking like it's much bigger. 4 cubed is 64. If we multiply 6 times 4, we're going to get 24. 5 times 5 times 5 is 125. And at this current moment, you're like, oh, hey, these are not that close to each other, but we found out 5 factorial is 120, and now they are very close to each other. So if we look at 6 factorial, 6 cubed is 216. If I multiply 120 by 6, we get 720. We can keep going. 7 cubed is 343. And 7 factorial is 5,040. So once we get to 6, we're going to kind of take over in our factorial versus our cubed. So one of the things that we're going to know is that a factorial actually grows very, very fast, faster than polynomials. So if we go back to what we were talking about earlier, we're looking at the limit as n approaches infinity of n cubed over n factorial. Because factorials grow faster, this goes to 0, which means it is inconclusive.